make sure there's no condensation risk. Triple pane windows, again, heat recovery ventilators, there's 2 of them. This is just a 2-floor building. So there's one upstairs and one downstairs, a large size one. And there's 300 CFM of air continuously. That's 150 each one, 150 each floor that runs 24/7 in here. Fresh filtered air, 24/7. Heating and cooling, okay, we have 2 floors. We have basically 4 zone, and we have 4 of these indoor units, 2 outdoor units of various sizes, and they're all modulate. You'll get to that. And the passive cooling at this point is just the bypass mode and windows. And one of the things about this particular building, and I'll show some construction photos, and when we get to this now, we'll very quickly see that again so you can, yeah, okay. So we said that was the old building that was there, okay, the dumpster ready to deconstruct, returning to auto setup, okay. Deconstructed, boom, ready, bring in the excavator to dig a hole, ready to go. Start taking the dirt out, boom, start the hole, and we got some form materials down on the bottom there. Does this look familiar, Dan? Okay, big structural slab, lots of steel, right? Pillars reinforce this. Now, one of the things that you'll see, and we'll get there, insulated concrete forms coming into the hole, start building up the walls. It's like Lego, right? Here we go. All right, now, one thing very unique about this building, very challenging in some ways, but unique, is you will notice, because of an ordinance in Palo Alto that says that the first floor can be up to, 3 feet, 36 inches above finished grade, okay? And if that's the case, the basement, okay, does not count in the floor area ratio used for zoning. Ooh, free floor. Okay, the problem is, okay, you only have 3 feet of clear space, and basements can be dark. This is a 6-inch thick post-tension concrete slab. Skinny. Okay, why? What does that allow you to do? Normally, I'd have open web trusses here that are 14 inches or 16 inches deep, and we'd have really skinny little windows, right? But the part of the design that allowed this was this post-tension concrete slab. Wonderful daylighting through the entire basement. Marvelous piece of architectural work. Now, that has implications for a mechanical designer. Oh my God, where are my service layers? There aren't any. There's nothing there. Okay, where do we run this stuff? Okay, challenging. Okay, but we have a passive house. We have ways to deal with it. Okay, so this was a buildup again, more concrete on the slab. We got the second floor. This is insulation, as Dan pointed out here in a previous comment. Okay, so the structural slab. Here's, I think we ended up with 4 inches, you said, David. 3, it was spec 3, 4 inches here below. Okay, and that's what allowed that detail where there's absolutely no thermal bridging to where the wall meets the floor. Here it is, the whole thing, nicely insulated, a slab. Here we go upstairs, starting to put those wonderful external, okay, that's external to the ICF forms. No thermal bridging whatsoever. Lovely thing. Same thing with the porch structure in steel. It's external. There's no thermal bridging there to speak of. Okay, even at the gable end here, it's ready to go. There's the sort of a typical roof structure that's going to get insulated inside. There we go. More detail. Roof, standing seam metal roof there. The windows are in. Oh, cladding is stucco, and then finished really nicely at the end there. Nicely finished. We're grading it out there, and we got a brick driveway and a lovely finished building. Okay, so there's a very, very quick sort of review based on Roy. The architect had some nice time sequence photos, so we just picked those up and to give you an idea of that. Fun to see that. Okay, so we're mostly going to talk about the mechanical system again, because you get the idea of the frame. It's a passive house. You get the idea from the previous thing about the specs. Okay, but here we have this situation where we have we don't have much room for mechanicals, and we have clients, if you will. We have the building owners who are not willing, okay, to give up much of anything additional for mechanical, for putting boxes of stuff. Yeah, but, okay, and well, this is common, right? They want the real estate for doing other things, right? For the music room and so on and so forth. So we understand this. If you're in the building design world, you understand this well. Okay, so we have, though, a low-energy building, right? We have this passive house that, as you've seen from the numbers, takes this teeny amount of energy, okay? So now our approach to HVAC can be non-traditional. In fact, it has to be, right? Because we can't use the big, giant boxes before. So almost no room for services for this sorts of range. And we have to deal, again, with this ventilation, heating and cooling, and air circulation. Now, this is a fun photo, right? Because at the heart of this mechanical system is 15 Panasonic bath fans. That's the core of the mechanical system I designed. Who else would put their reputation on the line with 15 bath fans? Well, the Japanese thought that was pretty interesting. So they were here in this country and they said, we got to see this. They're the manufacturers. So here's a group of executives and engineers from Japan, from Panasonic, that came to check this system out. So kind of fun. And we bow. David was here, and it was kind of fun. Okay, so here's the system. Same idea as that 1,600 square foot house, just on a bigger scale. This is what, almost 6,000 square feet, two floors. So what do we do? So here's a long section of the building. We have 2 floors, and we created 4 zones. Okay, we're in one zone down here in a common area. The other one you'll see when you tour is upstairs, where the kitchen and the great room is. Okay. And so each floor has both a common and what would be called a private room. These are other, there's an office and a music room and other things where small groups or few individuals grow. And then these are the bedrooms with some sleeping lofts in it. And you'll see here, where's the room for where's the ductwork? There isn't any. Okay, so we created 4 zones. We had experience now and we had some confidence, and we did, actually there's a German word for this. I was in Frankfurt at the conference, and there were some schools that were trying this, and they called it active, at least I don't know if this is the English translation, they called it active overflow ventilation or something, where they use this. And the idea really is simple. The idea is to use the common spaces, in particular the hallways, as ducts. Okay? Don't put extra ducts when you have a hallway, all right? So here's the idea. We take on each floor, this is the basement now, we have this common zone here, right? And there's the individual zone. And essentially what we're going to do is we're going to supply into the one zone, right? We're going to positively pressurize one zone and negatively pressurize the other, okay? All right? So the first thing is ventilation, all right? And this is so here you've got this thing here. There's 150 or 200 CFM right now. Coming in there, HRV, you'll see as you walk by, there's just a mechanical room in there, and the exhaust comes out of bathrooms. Simple, all right? Then we add on top of that mini split heat pumps, one here, one in the next zone here, which is the office, which is most commonly occupied, a very sensible place to be it. So we have heating and cooling happening, actually in this case, in both these areas, okay? But not directly going into these. But we add an air circulation function that runs asynchronously 24/7, okay, that delivers about 70 CFM typically into each of these rooms from the hallway. So it's negatively pressurizing that and positively pressurizing these rooms. It's drawing air from here through the hallway. Each one of these has a relief. If you look in each one of these rooms, there'll be a supply and there'll be an exhaust, a pressure, a jump duct, if you will, that returns back into this room. All right. Now, we know this works because we did it before on a smaller scale. And I don't, anecdotally, we've just sort of fired it up, but I mean, the impression, will you tell us, what's your impression so far?
It's really wonderful.
Okay.
The building is uniform temperature, and we got 8 kilowatts in here this morning, and feel it. Right?
Yeah, this is it.
And is it stuffy?
A little bit.
Right? So
It wasn't designed for a load of 75 people. Okay. So the same thing upstairs, really?
people are in the room right now.
60, 65 or something?
No way.
We've got 85 people
Okay.
in here.
Yeah, that was beyond our design parameters. Not
I
bad.
don't think the fire department should
This is turned on low actually too, because I didn't want to disturb the thing. All right, let's keep going. Okay, the same thing upstairs, sleeping area here, common room up there, you'll walk through it, hallway here, so very simple again. HRV supply all in there, exhaust out of the bathrooms, heating and cooling on this zone, heating and cooling in this zone, air circulation out of these hallways. So as you tour the property, look up in the hallways for grills for Panasonic bathroom fans. Okay? Now, what makes this possible? One thing was basically the fact that these fans are ultra efficient. They use DC motors, okay? And they consume, in this particular case, somewhere between 10 to 15 watts, depending on the static, sort of pressure that they have to work against. Ultra, ultra efficient. And with traditional fans, this wouldn't work because you'd be consuming too much energy. But with this, it's really wonderful. Okay, that's it. That was fast. Wow. Surprise.
May I add just one or two things about the building? One is that thanks in part to the generosity of Jeff and his fellow employees at Solar City, there's a 15 kilowatt solar array on this roof, and it was designed to serve the full needs of all three projects.